Okay, and then a trinomial is a polynomial of 3 terms. Okay, and something like that, an uncommon one you see is something like x squared plus 3x plus 4, something like that. But it could be 2xy plus 3x plus 4y, something like that could be a trinomial. So that's trinomials. Do we all understand that? Okay, so on the assignment 1.2, I'd like everybody to get that out. I just want to make sure you guys understand a few things. 1.2. Can I change slides right here? Is anybody still writing this? Okay, what's your question? Are you talking about this one? This one? What are you saying? All right, think of it again, ask me. Okay, so let's say you guys, everybody go to, did I do number 1 with you at one point? Let's go to problem number 4 on here, where you had negative 5x plus 2 plus 7x minus 13. Now, the topic said adding and multiplying binomials, and this one said add. Well, first of all, are these binomials? Is negative 5x plus 2 a binomial? 2 terms. 7x minus 13 is a binomial. Okay, so when we add like terms, in this case, we're adding 2 binomials, and keep in mind, that's a plus sign in between. So when you have a plus sign in between, you're going to just combine like terms. And so my like terms would be terms that have the same variables to the same degree. Notice this is negative 5x, and this is positive 7x. When I add those together, negative 5 plus 7 makes 2. So I have 2x. And the other like terms are the 2 terms without variables, 2 and negative 13. So 2 plus a negative 13 would make a negative 11. And so my answer is a binomial, right? In that case. Any questions on that one? Okay. How many of you were able to do all problems 1 through 5? Okay. Let's go to number 9 now. Everybody go to number 9. Number 9 was the same problem, the same 2 binomials that you were given in number 4. Did you notice that? Negative 5x plus 2 and 7x minus 13. And notice that there is no plus sign in between those. So what is that implying? Multiply. And they did say in the instructions to multiply. Use the distributive property, right? So I'm going to multiply these 2 binomials this time. And notice, when I multiply, I have to use the distributive property. Raise your hand if you don't understand what the distributive property is. We did it in 1.1. How many of you guys understand the distributive property? Like, for instance, if I had something like 2 times x plus 3. How many of you guys know how to distribute the 2? You get 2x plus 6, right? Okay, so that's the distributive property. However, we're going to use it a little bit different right here. We have this binomial times this binomial. Whenever you do that, you take each binomial over here and times it by each binomial over there. So I'm going to distribute the negative 5x. I have to do it to both terms. And unlike add, where I combine like terms, I just add 2 terms that are alike. This one I have to multiply the negative 5x by both terms, right? So I'm going to get negative 5x times 7x is negative 35x. And negative 5x times negative 13 is a positive, oh yeah, x squared. Negative 5x times 7x is negative 35x squared. Don't forget that x times x is x squared like I did. Negative 5x times negative 13 is a positive 65. So I've distributed the negative 5x. Now what do I have to distribute? The 2. I've got to times the 2 by 7x. There's a 2 by 13. 2 times 7x is 14x, and by the way, that should be 65x, right? And 2 times negative 13 is a negative 26. By the way, how many terms are in there? There's 4 terms, but they don't really have a name for it. It's a polynomial of 4 terms is what they say. Okay, some people want to call it a quadrinomial. I guess you could do that. Okay, but the thing about this is we have some like terms in there. What are my like terms? 65 and 14. So if I add those together, I get 79x. And my answer is, what kind of answer, you guys? A trinomial. So here's what I want to show you on this. Do you listen? I have 2 binomials. When I add them together, I get a binomial. I multiply these same 2 binomials together, and I get a trinomial. Now, it's not going to be like this in every case, but most of the time it will. Okay? And so they're a little bit different. That should help you answer question 12. How are they different? What would you say? Yeah, when you add them, you get a binomial. When you multiply them, you get a trinomial. Okay? But number 13 has the one exception there. Which one is the one exception when you multiply it together, you guys? Number 11. Okay, and I want to talk about that one right now. Okay, so if you go to number 11, we have x plus 5 times x minus 5. How many of you have completed this problem already and multiplied it? How many of you have not? Okay, it's okay. If you haven't, I just need to know. Okay, so everybody has? Say, what'd you guys get? So x squared minus 25, right? Why isn't it a trinomial? Who would like to explain? Everybody that knows why it's not a trinomial, raise your hand. If you know, raise your hand. I want to see how many of you know. Okay, who would like to explain to everybody in the class? Okay, Elison, go ahead. Because the x's cancel out? Well, yeah. Okay, go ahead over there. So they add up to what? 0. What do you guys think? What do you think? Fused? Is she right? Yeah, she's right. Because when we multiplied this, if I was to FOIL, I'd get x squared, negative 5x, 5x, and 5 times negative 5 is negative 25. When I add these 2 middle terms up, just like, what's your name again? What's her name? Kenna or McKenna? Kenna. Kenna said that you get 0 for that middle term, so you get the x squared minus 25. Everybody got that? So, how many of you guys in problem number 14 says try adding the 2 binomials in number 11? Wait, no, that's not it. In problem 13, you are supposed to come up with a couple more examples. I'm going to give you guys 1 minute right now. I want you guys to share with your shoulder partner some other examples of 2 binomials you times together and get a binomial. Okay, similar to this right here. So everybody, I'm going to give you 45 seconds. 45 seconds, go. Okay, let me have your attention back up here. Okay, were there any questions anybody wanted to ask about that? Okay, all right, I would like, thank you. Okay, thanks. Who's Jimmy, are you? Carter? Okay, it says during class, towards the end of class, we'll have some time you can go, okay? All right, any questions on that at all? Okay, I want you guys, now, I don't know if you guys noticed, I put you guys in, I might trade some chairs here. I'm I might have you guys go sit right behind those two. Not today right now, but I might trade you. Put you in groups of 4. Even though you have a shoulder partner that you're at with the table, you 4 are going to be a group. You 4 will be a group. You 4 will be a group. You 4 right here. You 4. You 4 right here. And then when I trade you guys will be over here, and you 4 will be a group. Okay. So right now, except for you two and you two, I want you guys to talk to everybody in front of you right there. I want you guys to tell each other some of the ones you guys got for that last problem we did. Some of those 2 binomials you times together and get a binomial. I'm going to give you 15 seconds. Go. Okay, everybody go to problem number 16. I want to make sure you guys understand this. I didn't go over this as well as I should have, and so I want to make sure we understand, okay? This, in problems 15 through 20, it asks you to find the perimeter and the area of these rectangles. Now, you'll notice these rectangles, these are all rectangles, and we have formulas for finding areas and perimeters of rectangles, right? By raise of hand, how many of you guys know the perimeter formula for a rectangle? Okay. What do you have? Perimeter equals what? Two lengths plus 2 widths, right? Okay. Because I have this length and this length right here. Lengths are opposite, widths are opposite, right? I know if this is a rectangle that opposite sides are congruent, right? So I know that opposite of x plus 1 is another x plus 1. And opposite that x plus 1 is another x plus 1. So this makes it a square, doesn't it? Since they're all the same. But usually, for finding the perimeter, I can add the 2 times these 2 plus 2 times these 2. Or I can think of it going 4 times in a square. I can go 4 times the width or length or whatever it is. Okay. The area. How do you find an area? Raise your hand if you know an area formula for a rectangle. Okay, what is it? Length times width. Is that what you said? Okay. Length times width. And so I multiply a length and a width together, right? So in these problems right here, all you had to do, 2 lengths plus 2 widths. Okay, so 2 times x plus 1 plus 2 times x plus 1. That's going to be, if I distribute, 2x plus 2 and 2x plus 2. I combine like terms, I get 4x plus 4, and that's what the perimeter is, right? Another way I could thought of it is just adding all 4 sides together. X plus x plus x plus x is 4x, and 1 plus 1 plus 1 plus 1 is 4, so 4x plus 4. Either way, I get the same answer. Okay? And then the area can be obtained by taking one side and timesing it by an adjacent side. And that's kind of like the problems we did in 6 through 10, isn't it? 6 through 11, I mean. So I'm going to go x squared. I'm going to get an x plus an x, which is going to make it 2x, and a 1 times 1 is 1. So my answer for the area is x squared plus 2x plus 1. How many of you guys got those 2 answers on that problem for that? On number 16. You got that perimeter and that area. Here's the perimeter. We got that by adding the 4 sides or using that perimeter formula. And here's the area. So do you see how we used what we learned in those first 11 problems on this? Okay, just a second. David? Okay, you can. It's the same thing as what we did, though. X plus 1 squared. But I'd like you to multiply it out. And, hey, you guys, a common misconception is that x plus 1 squared means x squared plus 1 squared, which is 1, which is not correct. Okay, because what do we forget to do when we do that? Yeah, we missed the 2x because we didn't FOIL it, or we didn't distribute it, right? So you don't actually go x squared 1 squared. You have to do x plus 1 times x plus 1. You have to distribute. Okay, so Keep that in mind. All right, this is what I want you to do, because I could see a lot of you guys didn't quite get that one. So right now, in your groups, I would like you guys to do, with your pair partner, I want you guys to do 17 and 19 and check to see if you got the same answer for both perimeter and area. Okay, if you've already done this one, help your partner. If both you and your partner have it done, turn to your other people and see if you can help them. Hey, the question came up because as I was coming around, I saw some of you guys don't have any work shown. Let me just tell you how I'm going to do this in the future. From now on, when I give you a homework assignment, I'm going to give you the answers. So I don't want to see the answers. What I want to see is how you got your answer. So I want to see your work. Now, I realize some problems are so easy they don't require work, but let's say you had something like b times b plus 3. I think this is actually one of the problems on your assignment, right? And some of you guys just wrote b squared plus 3b, right? Well, how can I show work on that? You can do this. You can say, okay, I times b, I got b squared, and b times 3. You can write that, or you can even write it in words. I distributed b to get b squared plus 3b. I want you to either explaining or showing somehow what you did to get your answer. Even if you think there's no work involved, there's always an explanation of what you did in English, okay? You can write it out. So I always want to see that. I'm not going to have you do that right now. I don't want to take the time. So, but in the future, that's the way it's going to be. All right, now, right here, guys, go to the last page. Oh, by the way, in 21, I want to hear a couple of answers. In fact, I'm going to give you guys, on problem 21, I'm going to give you guys 30 seconds to discuss this with your partner, and then I'm going to pick on a few of you, okay? 21. Okay, I am going to pick on a couple of you. Here we go. Let's go. You two on the front row. What did you guys write? Okay, what's all quadratic? The what? 15 through 20 are all quadratic, including the perimeter? Okay, so the area was quadratic and the perimeter was linear. I think that's a good way to put it. What do you guys think? The areas were all quadratic, whereas the perimeters were all linear. What? Oh, I did. Okay. I can't remember. I have a couple of classes of this, and so I don't remember which class I said what to. So, yeah, no wonder it sounds so good. All right, you guys go to 22 through 30. How many of you feel like you understand 22 through 30? How many of you are not sure? Okay. Okay, let me basically explain this. First of all, how many of you guys know what GCF stands for? Greatest common factor. In other words, we are looking for the largest number that goes into both or all three numbers, depending on how many they give you. Okay, so write this down in your notes. The largest number that will divide into a set of given numbers. It's supposed to be an N right there, by the way. Set of given numbers. The largest number that will divide into a set of given numbers. I want to look at problem number 25 to begin with. 7x squared and 21x. Now, I want to find the biggest number that will go into both of those numbers. Okay, well, if I look at just the 7 and the 21 first, just the real numbers, I know that 7 will go into itself, right? So, and it will go into 21. What I always like to do, you guys pick the smaller of the two numbers, because my number is never going to be bigger than the smallest number, right? Okay, so I pick the bigger number, or the smaller number out of the two numbers, and I always check to see if it goes into the bigger number. And if it does, that's my greatest common factor of the real numbers, right? Like this one. If it does not, then I can go down from there until I get to it. Now, out of x squared and x, you know, x squared won't go into x, but x will go into x squared. So you always pick the smaller out of the whichever one has the least number of exponents. So my greatest common factor of that one is 7x. And you can, if you were writing an explanation on that one, you can say, well, 7 is the largest number that goes into 7 and 21, and x is the largest number that goes into x and x squared. Like, what about it? No, you got to write an explanation. That's your work. That's yeah, and that, but an explanation like that is your work. Okay. All right. Let's go to problem number. Let's go to 49 or to problem 30 that has 49 s squared t squared and 36 s squared t squared. Okay, what is the largest number out of that goes into 49 and 36? Now I can start with the smaller of those two, which is 36, but 36 doesn't go into 49, right? So then you have to take half of 36, which is 18, because you can't have something between halfway to that number and that number that would go into it. So you go half of it of 36 is 18. Well, 18 will go into 36, but once again, it doesn't go into 49, right? So you can take some other factors of 36 that are less than that, like 9. 9 will go into 36, but doesn't go into 49. You can take 6. 6 will go into 36, but it doesn't go into 49. You take 3, goes into 36, but doesn't go into 49. And that, so 1 is the largest real number that goes into both of them, right? And so this, out of 49 and 36, it doesn't have a greatest common factor because, well, the greatest common factor is 1, but it's not gonna change anything, I think. And so this one is s squared t squared, right? And that's it. You could put 1s squared t squared, but do we usually put a 1 in front of a variable? We don't usually do that, okay? So we got that. All right. You guys get that? I'm going to give you 2 minutes before we correct this assignment to, with your shoulder partner, go over any of those last few problems right there, and then we're going to turn in the assignment, okay? Okay, Alex is going to show us how he got the answer to that problem. Okay, so he's writing a table of values. Okay, this is for the Macho Man thing. I say that for if you guys are listening to it later on. Okay, this is for the Macho Man thing. Okay, tell us how you got it. So this is the one where, like on the 5th day, he's had a total of 35 push-ups for the month, right? What's he going to have the 6th day?
48.
48. So, okay, so 6 days he's going to have 48. How did you come up with that equation?
I simplified it. That's how it is.
Okay, well, tell us, how did you come up with 1/2 x and 2x plus 4? Do you remember? Because these guys need to know how to get this. So the second set is a constant difference, right? Okay, so how did that help you? If you what? Okay, that's where you get 2x. How did you get the plus 4?
Because it's 2 and it's half of 4 is 2.
Half of 4 is 2.
Which is the... I don't know, I just plugged in random numbers so here.
Oh, so you did it by guess and check?
Yeah, that's what
Okay, so he used guess and check. Did anybody else use guess and check? Okay, Christian, come show us what you got. Circle it and hit the middle.
Yes. Okay. So we have this equation.
Doesn't Christian look smart in those glasses, you guys?
Plus 1. Alright, that's how we get the number that he's going to do that day, right?
You guys all got that for your explicit formula? Because you guys noticed that there was a difference of 2, so that's the 2x, but plus you had to add 1 to get the number, okay? Gotcha.
Okay, so you said, like, we take the one that we're trying to figure out, so say we're trying to figure out 4. So we have 24, and we also add 3, making it 27. Is that not right? No, okay, hold on. For 4, we have, he's going to be doing 9 for that day. The total would be 24, but he's only going to be doing 9, so you take the 9 and add it with the 3, making it a 12. Then you cut that in half, making it 6. Alright? And then you times the 6 by the number of, like, the function number that you're trying to get. So you times that by 4, you get 24.
So you're saying that you take, so if you're going to the fourth term, you go clear back to the third term before it?
Third term. Yeah,
3 terms before?
You take the first term. You're always going to go back to the first and you add the...
Oh, you always go back to the first term?
Yeah, you add the 3.
So you take the term number you're on for that day. So like on the 5th day, how many did he do? 11?
Yeah.
So so we're on 11 on the 5th day. You add 3 to it, the first days.
14.
You get 14. Oh, because you're using that method I showed you, that little story I told you, right? Of adding the first and last one,
Yeah.
dividing by 2. Okay. And so
You cut the 14 in half, it'd be 7. And you times that by 5, it'd be 35. So if you're going to make an equation out of it, you do f of x equals, and then you come back and you start with this because that's how you got the 9 and 11. So you did the 2x plus 1. Then you're going to go and you're going to add the 3, and instead of just adding another 3, you can make this a 4. And then you divided that by 2. So we divide it by 2. And then we know after you do that, then you come back and you times it by what? Which one you're trying to get. So if it's 4, so you're going to be timesing that by x.
which is 4. Well, okay, x right there. Okay, yeah.
Simplify that. Distribute that. X times x plus 2. Distribute that. X squared plus 2x.
Excellent. Give him a hand. Okay, good job. All right. Okay, so, these quadratic ones are a little bit tough, you guys. As you go out throughout the year, hopefully you guys will start catching on to them. Linear and the exponential should get right off, okay? All right, so could you guys answer some of the other questions on there? Like, how many push-ups will Scott have done after a week? Can you answer that question? Okay, so all I'd have to do is plug 7 in here, right? 7 squared is 49, plus 2 times 7. So I get 49 plus 14 is 63. Yeah, there is a recursive for this. Okay, sub n equals a sub n minus 1. And since the difference between terms is 2, you know how the second set of terms? Okay, then it's going to be 2n. And like if you, so you got to just add 2 every time. And if you notice, the difference between these terms was 5. Oh, wait, yeah, 5, and then that was 7. So this difference was 2 right out here. So it's 2, and on the first term, 2 times 2 is 4, but you got to add 1 to get the 5. So it's going to be plus 1. So there's the recursive formula for it right there. Okay? That's where you get the recursive formula from. I don't want to spend any more time on this problem right here, you guys. So okay, now this thing right here, you guys, this is not your homework assignment. Okay? That's a task that we did to try and help us learn about explicit and recursive formulas a little bit more. Your assignment is this one right here. However, I would like everybody to have one of those. Okay, we're going to go to 1.3. Okay, I want you guys to look at number 1. Number 1 says 2 to the 4th times 3 to the 1st times 5 squared, right? Now, without a calculator, this 2 to the 4th means, if you know what 2 to the 4th means, raise your hand. I just want to see how many of you know. 2 to the 4th, what does that mean? If I expand that out, what would it mean? Tell us what it means. Okay. Then times 3. We might as well keep the dots since we're using dots, right? Times 3 times 5 times 5, right? Because 5 squared means you're timesing 5 by itself twice. And then you're supposed to go 2 times 2 is 4. That time that is 4. 5 times 5 is 25. 3 times 25 is 75. 4 times 4 is 16. And then you can go like this. 5 times 6 is 30. 7 times 6 is 42, plus 3 is 45. 1 times 5 is 5. 1 times 7 is 7. That's 10, carry the 1. That's 12. 1,200. How many of you guys got that? Okay, it says multiply each number to find the whole number that each factorization represents. So yes, that's what you're supposed to do. Okay. Go on to, everybody go to number 6. Everybody go to number 6. 2 times x minus 9 times x minus 4. If I was multiplying this together, do you guys know which ones to multiply together first? Do I times the 2 by this first? Or the x by 9 by that first? Or does it matter? Actually, order of operations, since this is multiplying, it doesn't matter which order you do it in. Okay? I personally, I would times x minus 9 by x minus 4 first. Because the 2 is easy to times by something afterwards. And if you times the 2 through first, then you're going to have bigger numbers to work with right there. But you can do it either way. It doesn't matter. I'm just telling you what personally I would do. Okay? So I'm going to go x times x. So I'm going to have 2 right here. X times x is x squared. X times negative 4 is negative 4x. Then I'm going to distribute the negative 9. So negative 9 times x is negative 9x. Negative 9 times negative 4 is a positive 36. If I combine like terms in the middle, that's a negative 13x, right? And then if I distribute the 2 through, I get 2x squared minus 26x plus 72. And there's my answer. Okay? All right. I would like everybody to do number 8 in your partnerships and check to see if you got it right. Number 8. I'll give you a couple minutes to do that one. Number 8. Okay, everybody, let me have your attention back up here. Everybody go to 16. Number 16 on the back. At the bottom. I need your attention, you guys. You got to stop. Okay, we got to move on. Number 16. Everybody go there. I've written it up here on the board. Okay. On number 16, it gives you that f of 0 equals negative 5. Okay, and it says it wants you to write the first 5 terms of this sequence. And it gives you a recursive formula. F of n plus 1 equals f of n plus 8. By the way, just curious, how many of you guys know how to do this one already? Nobody in here knows how to do it? Okay. Okay, if you haven't looked at it, how many of you think you can figure it out if you looked at it for a second? Okay, good. Okay, let me just show you right here. Everybody ready? Okay. If f of 0 is negative 5, that's tell me what my first terms are, right? What are they? 0 and negative 5, right? So I want to get the next term in the sequence. Well, this is a recursive formula. N plus 1 means the next term, doesn't it? So to get the next term, what's my next term? 1, right? My next term is 1. To get the next term, to get term 1, I take the previous term, f of n. Because n is before n plus 1, right? You know how we've been doing n over here and n minus 1 over here? It's the same thing. It's just the n plus 1's here. It's 1 more than n. So the next term, and you add 8. So what's it tell me to do to get the next term? Add 8. Negative 5 plus 8 is 3. The next term would be 11, because I add 8 to 3. The next term would be 19. The next term would be 27. It says the first 5 terms. There's the first 5 terms right there, right? That's all I do. Can you guys handle that? Okay, I want you guys to all do number 18 together right now. I'm going to give you a minute. 18. Okay, so your assignment, you guys, this is what your assignment's going to be. It's not going to be this whole paper. It's going to be these 8 problems right here. 2, 5, 9, 11, 13, 15, 17, 19. Everybody's going to need their own paper to take home, and I want you to write your homework assignment. Well, you can do it on here, okay? And I want you to show your work, or an explanation of how you did it. Yes? Which 9? Are there 2 9s? The first one is the one I was meaning. Okay? The first 9. The 2 times 5x minus 7 times 3x plus 1. Okay? So, does everybody understand their homework assignment?